All right, day 3 of our journey. Today, we're going to talk about optimizing our code using some, I would say, Terraform tricks and making our template reusable by adding variables there. So, and to start with, I'll ask you a question. What you might think in this configuration is not optimal? What might be not perfect from the, I would say, general um, uh, ideas of programming? What we could have improved? Not dry. Very good. Vitor, could you please take a word and explain what exactly means dry?
Do not repeat yourself.
Yes,
so
that's right.
We could use like the count argument to
Very good.
just
Looks like you're very comfortable with Terraform already. You not only said what's wrong, but explained how exactly we're going to fix this. And this is totally right. Exactly. So let me expand this. So we have 2 subnets, 2 NAT gateways, 2 route tables, 2 whatever number of AZs multiplied by our resource. So this means these two resources, these two resources, these two resources, these two resources, and so on, essentially duplicate each other. So the difference between first subnet and second subnet, only this number and this number, and actually this letter as well. So what we can do is reduce the number of lines of code, still achieving same result. So why it is important? Because bigger number of lines, more lines we have, more probability of error we'll have. Or let's say, for example, we want to update, like add some option here, right? I don't know, DNS support, for example. And this will mean we'll have to copy and paste it also here. But what if we, for example, have 10 similar resources? This means we have to repeat this operation 10 times. And that's not optimal. That's something we should avoid. So what essentially we can do is introduce the thing called count. And let me actually do this. I will comment out all everything, but no, actually no. I think I forgot something. Who can advise to me what I have forgotten to do? What should I have done before jumping into editing code?
You have to commit your code, pull request, and then you have to pull it from the main branch, the code, fresh code.
The code already committed. This is what we've done last time. Let me make sure that I did not forget to merge it since yesterday. I will go to GitHub. Here is my repository. Pull requests. Yeah, and there is an outstanding pull request that I haven't merged. So, but ideally, I could have done this yesterday. So I did not complete my home task. Squash and merge. Check out main. Pull whatever I've just merged. And create a new branch. I'll call it count. Only after that, I can start changing my code. I can start working on my code. So I will only keep these 3 resources for now for the demo purposes. These ones, I'll comment them out. So what we're going to do, instead of repeating them 2 times, I will delete this one and use count equals 2. And what it will do is create some sort of a loop. So it will go 2 times and create 2 resources. And also, instead of public 1, we should call it just public. Same here. Let's save it and run Terraform apply. There is an error. 10.0.0/24 conflicts with another subnet. Why is that? Because
CIDR.
yes, very good. But Christopher, could you please
Yeah, I have a conflict with the CIDR.
could you please use headset because I have echo. I can't hear myself. And when you want to add something, when you want to ask something, please don't just jump in. Instead, there is a raise hand button like this. And yeah, very good. Thank you very much. And this will allow us to keep this conversation focused and organized. Thank you very much. And now you can add whatever you wanted.
The problem is the CIDR block, and because you are creating 2 of the same resource, you're repeating the CIDR, so it needs to be different.
Okay, very good. Exactly right. So how do we fix that? Easiest solution is to so-called interpolate. This means whatever is inside these curly bracket and $sign will have will be translated from a variable, and there is a special variable called count.index. Let's try this. So now second one will be 1. And we can go and check what we've got in our AWS console. We can go to VPC. We can go to subnets. And here's the thing. We have now 2 subnets named public. Even though they have different CIDRs, it's a good idea to also somehow distinguish them as well. Again, what we can do is add these $curly brackets and press count.index. And also one more thing, they are running in the same availability zone. But how do we translate, for example, 0 or 1, which is recorded here, into A or B? That's a very interesting and good question, and I will expand it a little later. But for now, let's run Terraform apply again. Let's refresh, let's check it again. Now it looks much better. let's move forward and repeat the same with our private subnets. Let's call it private. Let's have count equals 2. Again, count dot index, count dot index. Let's try this. And we have an error again. Again, same conflict. This time we have public subnets that conflict with our private subnets that have same CIDR. And what we can do, whatever within here supports also different transformations, I would say. For example, we can add 2 to this count.index because we have 2 public subnets which start from 0 and 1. And here we have count index, which is 0 for the first one and 1 for the second one, plus 2 means it will be 2 and 3. It might look very basic, but later down the road we will complicate it even further. And in fact, I'd say that even though we managed to overcome this problem, let's say we want I don't know, e-subnets. I believe it will not work anymore. It tried to create 10.0.2, but we already have it here. Not very good, not very flexible. And in fact, we can improve it further and at the same time solve this problem of having now all our subnets in the same availability zone. So let me show you this. We can declare, let's say, a local variable using the locals block. And in this block, we can define everything that varies, everything that changes across our different instances of our resources. For example, we can define public ADR, or we can define private ADR, and we can define availability zones. And these square brackets means it's a list. There are different data types. What you see here is called string. By string, it means like a regular text, regular text. And there is also integer, which means number, or there is a list. It is basically a collection of several objects. That can be anything. String, another list within this list, object, and we will cover them in more details later. But for now, let's declare a list of strings which declares which CIDR blocks we should use. But how do we relate this to this? And the answer is easy. What we can do is basically how we call this. We can call it just same way as we do for our properties of our resources, like this one. We can say local dot public CIDR, and for example, when we type number 0, it will all arrays starting from 0. If you're not aware, at least in programming world, we count from 0 almost always. And 0 means element number 0, essentially like a first element in a traditional counting system of humans. 1 means go to this list and take this one, and so on and so forth. And what we can actually do is do this one. So what instructions we give into Terraform? If there is a first element that you created, or actually 0th element that you're creating, take this property. If it's the next one, take this property. Same with availability zones. We can type local availability zones at count.index. And over here, we can keep whatever we have, but I'll add +1, so it's more like human-friendly, more readable. And just repeat the same for our private subnet. +1. Availability zones. This one will be similar, but private CIDR. It and run Terraform apply. It is trying to recreate something. Why? Because as we've seen previously, some properties like availability zone, when they change, they force the recreation of a resource, because we either need to transfer these from one physical location to another, or some other disruptive changes are required. And very interesting thing here, we can set this, for example, to 0 and run Terraform apply. And it will then create 0 resources. In our case, will mean destroy. But in our case, let's keep them set to 2. I will do one more thing. I will change this slightly, and I will explain why I do this. Public CIDR will start from 0, and private ones will start from 100 and further increment. Also run Terraform apply one more time. Cool. So now what we need to do next is finish with the rest of our resources. This is AWS Internet Gateway, route table. We don't need to change anything here since it's 1 per VPC. Route table association. Our candidate. Route table association, public. We want 2 of them. Subnet. How do we reference to them? We have 2. We can still connect to them by index. So similar way we declared the list manually, when we use count, the resource is, I would say, contained, is added into a separate list of resources that can be in turn referenced using, for example, public at 0, public at 1, or public at count.index. What index should we add to our public route table? Can anyone give me a hint? Yes, Sabina.
Oh, yeah. Depends though, but for this particular case, we would use the count to track the resource count
Count.
index.
Which count.index,
Yes,
like this.
yes.
Are you sure?
Yes. Doesn't I could do this. You could also, yeah, I think that's what would happen. So that it would pick up the zeroth route table, the two route tables you created, the two public route tables.
Okay. Probably Sanjeev has something to add.
So the route table need to have like a one-to-one mapping, right?
How many?
Yes,
The question is how many public route tables we have.
Oh,
We just created one, right, to IGW.
Yes, we created one. This public route table has route to internet gateway, which is one per VPC. This means we still okay to have one public route table.
Oh, so then we don't
Yeah,
really need to index it then, right? It's only one.
that is totally right, and that's the reason I asked this. We don't need any index here. Both first public subnet that we referenced using count index, and second one, both of them are connected, I would say, many to one relationship to our public route table. Moving forward, Elastic IP. Seems clear, right? Yes.
Don't we want to put the NAT of count index because we want to name the resource NAT for both the EAPs, or?
This one?
Yeah.
No, count index does not need to be specified in the resource identifier itself. You can notice that here we only have public, main, but properties of resource, yes, count index
Okay.
is everywhere. And by the way, that's good. This one doesn't have anything. Yeah. So I'd rather remove one from here, and let's move forward. And I see several raised hands. I remember I see you guys, but let's just move forward for now and just keep this hand raised if you still have a question. And when we have a minute, we'll make a break and discuss your questions in more details, if they still be relevant. Yes, good idea. We can also add, by the way, tags for Elastic IP. Next question. So similar to what we had with our public route table associations, what we could have added here, what we should add here? Should we have no index, count index, leave it at is? What's your suggestions? Yes, Ramraj.
Yeah, we need count index here because there are 2 route tables for each one for one private subnet.
Yes, totally right. Okay, let me quickly go through questions in the chat. 2 route tables, Elastic IP tag supposed to be not count index. No, Elastic IP tag can be where it is. Yeah, probably we can either call it like main or yeah. Let's have it net here to be consistent and show that this is consistent to that. Okie dokie. So now we reduced the complexity and number of lines in our code. I'd say maybe 1.5 to 2 times. Run, and we can run Terraform apply. Count index +1, count non-counted context. Yes, some errors. Sometimes this happened. Route table private. AWS. I forgot to add count here. Count equals 2. While it's creating, we can discuss questions if anyone still have any. Yes, Vyacheslav.
What will be the use case for want to use locals and want to use the variables?
Locals is for something that's not exposed to outside, that's within your configuration. When you create some, I would say, constant, when you want to like merge some complex string into one and or something like that. And variables is something that like when we need to obtain this value from outside somewhere, for example. Yes, Sanjeev.
Is there any validation we can do? Usually we have like exception handling to check the number of elements in an array, right? So anything like that can be done with Terraform or that's not possible.
Terraform plan and Terraform apply themselves validate the correctness first, and only after that trying to apply. Also, there is a command called Terraform validate that you can use, but it's essentially similar to Terraform plan or Terraform apply. So the short answer is just run Terraform plan.
Okay, thanks.
But at the same time, successful Terraform plan will not guarantee that that apply will run successfully, because you never know what your provider will return and how it will react, right? Yes, Ramraj.
So what if you want to import some variables from other Terraform files within the same?
Good question. We'll have a separate class about that in like maybe next week.
Okay.
Yes, Piyush.
So we are giving a CIDR block as all zeros. So any traffic going to even in the internal network going through the net gateway?
Yes,
Or
that's right. For private subnets, which are associated with our private route table, all internet traffic will go to NAT gateway. And these all zeros are basically a kind of catch-all rule that allows us to achieve this.
so even there would be a internal communication between the subnets, it should go via net gateway, right?
No, that's not right. There is a separate so-called default rule. Let me show it to you.
Mhm.
This one, right? See,
Okay.
and you can never delete it. Amazon will not allow you. And if the destination is CIDR of your VPC, it will remain locally. And this range, if we count the number of IP addresses here, is significantly smaller than this one, and smaller range goes first. So,
Okay.
which means local stays local.
Sure. Thank you.
And for some reason, it's not able to. It's always giving something new every time. So, interesting thing. When I go here, I already see that my route table has been associated successfully, right? Private 1, private 2, everything that as we expect. But for some reason, Terraform itself wanting something else, trying still spinning. Yeah, it took them 2 minutes and 45 seconds to only associate these two resources. And again, always something unexpected happening, and it should have been done much faster. Okay, so we are good on this front. And now a question. So if we want to, for example, expand our network and have, let's say, 3 availability zones, and that's the reason, by the way, I have started my private CIDRs from 100, so that when we add, for example, 10.0.2.0/24, /24, it does not overlap with this first private. And here we'll have 10.0.3.0/24 as well. Oh, sorry, no, 10.103. And one more availability zone, which is US East 1T. Let's run Terraform apply and see what will happen. Nothing. Can anyone guess why it is not discovering the changes that we've made? Yes, Ramraj.
Because we set the count to only 2, so it's not.
Yes, that's right. This means we need to go here, here, and here, here, also here, here, and change it to 3. Don't you think it's a problem that we had to repeat same operation like 4 times, 5 times? And the answer is yes, it is indeed a problem. And we're kind of, I would say, still breaking the rule of don't repeat yourself. The idea is very good, Ahmed. We can define it as a global variable. Let's try this first. Yeah. And the second idea is also great, but let's try first global variable so we can kind of improve our solution step by step. So for example, let's say count equals 3 and have it like this. Count equals local count. Local.count, 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 and local.count, and here as well. It's safe. Let's try this out. Yeah, it is working now. But yeah, we can go beyond just that and use special thing called internal function. Function is something, is some abstraction that accepts some inputs and produces some output, some processing, doing some processing. So let me demonstrate you this. Let's define some test output and say output count value equals local.count. What it will do? It will show us that there will be a Terraform output, and let me demonstrate this to you. Yeah, this one, changes to output, which is 3. Just exactly as we defined. Basically, it took this variable that is recorded into this local count and displayed it to us. This is how we can, for example, debug something when we need to test some configuration and find out what is written to this variable or what is written to that variable and so on. But what we can do, yeah, we can get rid of this and we can count how many items we have in this list. And this is done using a function, for example, length. And what it will do is it will check this variable, it will count how many items we have in there and return this value to us. So let's try, let's add one more line, n.0.3.0/24 and run Terraform plan. And we should expect let's real quick replace it back to 2. And what we should expect is the number 4 in our Terraform H. And number 3, yeah, thank you for pointing this out. I just saw that you written this in the chat. Count equals 4. That's exactly what we need. And what we can do with this? We can replace our count equals 2 with this function like this, and it will automatically add the required number that we specified here. Let's remove this output, we don't need it anymore. And I'll real quickly use replace functionality so that I can do this faster. But just a second, over here we should have private CIDR. And this one is okay, public. NAT gateway can also be correspond to, this one should be private. This one will be private. Now when we run this, it will automatically recount everything and dynamically readjust the configuration. We'll hit yes. Yes, Sanjeev.
So while we're practicing the syntax, right, as a newbie, these functions and all, is there a way we can just output and then check the anticipated result with the syntax is working fine?
Yes,
you can
run Terraform plan. And when I was demonstrating this, I was running Terraform apply, but did not hit yes.
Okay, thank you.
Any other questions while we are waiting? Okay, then in the meantime, I will use this time to just go check this again and save everything and commit. So this is our, let's say, first task for today, but we are not done yet. We'll have another one. Yes, Ramraj.
So we, at least like at my organization, we use Bitbucket. Every time we are pushing, we are saying git push origin and the branch name. Is it like a git thing? Because on Bitbucket, I usually do like git push and the name of the branch. Or just do a git push from the branch.
It's a git thing, and there are like many flavors you can do git push. You can run, for example, git push -- set upstream, and this means you no longer have to write this origin main, and it will remember your origin, and it will remember your branch, and you can just run git push.
Okay,
but that's always depends. Second task for today. So we already have our infrastructure deployed, but automation means we can reuse our results. Yeah, we can create more than one deployment from a single template. And what I will do is precisely this. Let's say that I will clone yeah, there are much better way to deploy multiple Terraforms, more than one, but for now, I'll just clone it once again. I will step out my current repository. I will rename it. Let's imagine we creating an office network, and one location that we have, let's say Orlando, right? Now I will clone the same repository. And the second one will be, what city should I choose?
San Francisco.
San Francisco, okay. So let it be just SF if you don't mind, because San Francisco is rather long and has dash also. Hope this is fine. And let's cd into Terraform in 21 days SF. And also, let's make sure we have latest code indeed, use content length, okay. And run Terraform, apply from here. We will run Terraform init one more time. And run Terraform apply. And hit yes. It started to create. It will create everything successfully, but there will be, I would say, side effects. So probably some of you have been in system administration world already. And can anyone tell me what happens if two offices, two networks have the same CIDR range, for example? Yes, Christopher.
We'll have a CIDR conflict.
Yes, that's right. That's right. And in fact, there is a huge pain in system administrator world when, for example, companies are merging and they, for some reason, had like two identical, very popular IP ranges. For example, 10.0.0.0 is like extremely popular, and it's like maybe each company that runs some sort of network might have this private IP range, and it's a big problem. And in fact, when we're designing a network, we must have unique CIDR blocks. Yes, we can have problems with VPC peerings, with any type of interconnection. VPC peering is one of the examples. Yes, totally right. Exactly. One more problem. Let me go here, refresh it once again. Now we have public 1, private 1, public 3, so on and so forth. Which one is Orlando? Which one is San Francisco? Can anyone tell me? No one can tell me. And this is something we need to do as well. This is we must have, same for VPCs. Yeah, the main, right? We need to somehow identify, somehow distinguish what we have deployed, and of course differentiate our CIDR range. And here is where variables come into play. Let me reopen this in folder. So what I will do, I will create new file. call it variables.tf, and declare a variable. Call it city. Or I'd rather call it env code. And instead of main, everywhere, we will have our variable env code. Env code. And we will also interpolate this variable into each resources within our VPC, within our environment. Why it is needed? Exactly just because like I described. So we can have quick look at our subnets and find out that this subnet belongs to Orlando, this subnet belongs to San Francisco, without having to click on it, check which VPC, and so on and so forth. And I would say it's a very important task, and good cloud architect, good solution architect should be responsible for defining proper, I would say, formula, proper naming convention, proper rule of how we name our resources, so that it is clear for everyone else, for everyone who logs into this account and first see our infrastructure, so he or she can identify what thing belongs to what. Okay, very cool. So if we run Terraform plan right now, it will actually it's different one. We need Orlando. It will ask us which variable we would like. Let's say Orlando. But does it mean we have to type everything again and again? But what if we have like 20 variables? We can automate this further. We can define a file called terraform.tf_vars and define values for our variables here. Env code equals Orlando. Let's run Terraform apply one more time. And now it's not asking us to provide this. It took this from terraform.tf_vars automatically. And actually, there is one more thing, and please accept my apologies for that. I'm forgetting. I keep forgetting like very essential thing. I did not create a new branch and immediately started making changes. So let's not repeat this mistake anymore. And we can, by the way, still check out main. No, we are not able to do this. Okay, never mind. My mistake. I'll do this way. I will save it into a separate file. I will reset everything. This .back file is not tracked in Git, so it will remain even if I reset. And what reset is doing is it basically returns all saved files into its original state as per last commit. We can now git checkout main. We can pull git pull and when I run git status, it should show us these three files as untracked, and it is okay. So what I will do, I will completely copy this. I will paste it back. We no longer need this back file. Terraform TFR's variables remain the same. Don't forget about trailing new lines everywhere. Let's run Terraform apply and hit yes finally and see what will change. Terraform apply, yes. Apply complete, resources 0 added, 18 changed, 0 destroyed, everything is good. What we'll see here is, yeah, very cool. So now our Lambda VPC is marked with its environment code, and each resource, route table, VPC itself, yeah, is marked with our environment code. It's not necessarily should be a name of the city, right? Maybe it's an environment like dev, stage, prod, whatever. Maybe application name, front end, back end. It all depends on the context, on the final state of our infrastructure. And also, let's parameterize our CIDR range. So basically, we will do this. Instead of locals, we will have public CIDR variable, private CIDR variable, and we will move them into TFVARs instead of locals. And availability zones will remain, but later we'll as well get rid of them in favor to some other cool feature of Terraform that will also simplify this. Terraform.tfrs, public CIDR, private CIDR. And also VPC CIDR as well. Let's run Terraform apply. It should show us that there are 0 changes. Yeah, and I forgot to replace. We no longer have locals. Everything now is variables. So instead of local public CIDR, should be var public CIDR. And instead of local private CIDR, it will be var private CIDR. Yeah, all great, all good. Let's commit. We'll create a pull request. Review everything, make sure everything is fine, make sure we don't have anything that shouldn't be there. Create a pull request. Once it's reviewed, we squash and merge, or just merge, whatever most suitable for you. And what will I do next? Just for demonstrating. Yeah, remember we have two folders, two environments now. Again, using folders to deploy multiple environments is not the best way, and we'll later cover more optimal solutions. But for now, just to keep things simple, we will stick to this. These two folders still pointed to the same repository. We can run git pull. And for example, let's open this in our code editor as well. So here is our second variation, I would say. In our variables, we can go and change it to SF. We can change our CIDR to, for example, 10.1. And run Terraform apply. This time, this one is just for the demo purposes. You don't have to deploy two VPCs as long as you implement the same. Just make sure you use variables. Make sure you use environment code everywhere, every time. And this will be it. This is this will be our way of moving forward. While it is destroying, any questions? Yes, Piyush.
Yeah, I had a question earlier about that. Why we can't do the checkout from the main branch, and we got the error. I mean, we can check out anytime from the main, right?
We can check out. So last time what happened is that I edited a file, saved it, and did not commit. When you have your repository in this state, you are not able to switch branches because you have not committed file. And what I essentially did is I saved this file to the second location outside that's not tracked by Git. And reset all my changes, and only after that checked out.
Sure. Thank you.
So if you would like, you can stay with me, guys, in this call. we will allow this VPC to be recreated, and I will prove that everything changed as we expect. Yeah. Otherwise, that's everything that I wanted to show, and talk to you tomorrow.